Hello everyone and welcome. In this video we're going to be checking out Honda's Adaptive Cruise Control, ACC, as well as its Collision Mitigation Braking System, CMBS. Now both of these systems are a part of Honda Sensing, which is an available suite of safety and driver assistive technologies. And of course a huge thank you to Honda for sponsoring this video. Now as far as hardware, two of the most important pieces used for ACC and CMBS are a millimeter wave radar, which is located up front concealed behind the grille, and a camera that is mounted between the rearview mirror and the front windshield. Radar is good for measuring the distance of vehicles ahead and their change in speed. That said, any metallic object can return a signal. That's where the camera comes in, as it's much better at object recognition, though not as good at judging distance. Before getting into how each of these systems works, it's important to understand the electromagnetic spectrum. This is a range of electromagnetic radiation ranging from radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, and gamma rays. Waves are defined by their wavelength. This is the distance between wave crests, and their frequency, the number of waves that travel past a given point per second. Our eyes see waves with a frequency of about 430 to 770 terahertz. This is the same frequency for which the onboard camera is useful. A radar system views an environment by interpreting a different wavelength. The range from 30 to 300 gigahertz of the electromagnetic spectrum is referred to as the millimeter wave band because the wavelengths of these frequencies are about 1 to 10 millimeters. Honda's millimeter wave radar system emits waves at a frequency of around 76 gigahertz. If, for example, you're in a dark room, this is like the radar sensor without emitting waves. You turn on a flashlight and the light waves bounce off of the surfaces of the room and this light returns to your eyes. Your brain interprets this information and you know what is in the room around you. The radar sensor works in a similar fashion, but instead of seeing visible light, it interprets millimeter radar waves. So how does adaptive cruise control work? The primary purpose of the system is to travel at the speed selected by the driver, just like traditional cruise control. However, if the vehicle detects another car in front of it that is traveling at a slower speed, the vehicle will reduce its speed to match that of the detected car and then maintain a selected interval behind the car. The system works by emitting radar waves which bounce off of vehicles ahead and return to the unit. This informs the system of the distance between the two vehicles, and changes in that distance inform the system of the vehicle's relative speeds. Throttle position is adjusted to maintain a set following interval, or light braking can be applied. Now, how does the collision mitigation braking system work? The goal of the system is to alert the driver if a collision with a detected vehicle is likely, and then to apply the brakes to reduce the severity of a collision if it's unavoidable. The system scans up to 330 feet of the road in front of the vehicle and works in 3 stages if the driver begins to come close to a vehicle detected ahead. For stage 1, the system flashes a brake warning and can also provide an audible warning. For stage 2, the system provides visual and audible alerts and applies light braking. For stage 3, strong braking is applied to minimize forces of the collision once it's determined to be unavoidable. Sometimes the system will skip one or both of the first 2 steps if conditions require. For more information on the technology involved, you can check out the links in the video description. As always, feel free to leave any questions or comments below. Thanks for watching.